Hello everybody, welcome back. Today we are going to be dealing with functions. Now we want to test whether something is a function or not, but let's go over the terminology of what type of functions actually exist and what tests can we use to see whether something is a function or not. So let's consider the following. Let's consider some straight line function, right? Let's say it looks something like this and it's continuous. And we can call this function f. So therefore, what we are going to say is that we notice that if we take any point on the x-axis, let's say we take an x value here. Let's say this is x1. Then therefore, when I lead this up to the actual graph and I find what the y value is, the output, then therefore our answer will be f of x1. If I take another point, let's say x2, then therefore I lead it up all the way to the function, and then I get an output, we get f of x2. Do you notice that for every single x value, we get a unique output? There's no like other output that we get from x1 or x2. We just get x1, f of x1 or f of x2 from either one of them. And this is basically going to give us x1 and f of x1 as a coordinate there. Then this one would be x2 and f of x2 as a coordinate as well. This type of function for when we have one x value with a unique output, we call this 1 to 1. This is a 1 to 1 function, meaning for one input we get one output. What about the other type of function that we learn about? So let's consider the following, right? If we have a parabola, let's call this g. And if we take a point on the x-axis, or let's actually take a point on the y-axis, okay, we call this f of x3, okay? And if we lead this to the function, and then go all the way to the x-axis, notice that the input that we're actually getting from this is x3. Because when we plug in x3 anyway, we are going to get f of x3. Okay? And then let's lead this, because you can see that there's another part of the function where it can intersect, right? If we lead it all the way down here, then notice that at that same y value, we have a different x value, which we can call x4. So what do you notice here? In this case over here, we have two different x values with the same output. So basically, we have many inputs that give us one output. And we call that in English many to 1. Okay, so this is the second type of function. So this is the first type of function, and this is the second type of function. And by the way, these two types of functions are functions, but then when we get to the line tests, which you're going to see the vertical and horizontal test, we are going to determine whether something is also not a function, and then you'll see whether something is not a function. Okay, so let's just get into the vertical line test, and then we can see what is not a function from there. Okay, so here is what we have. Okay, so we have four potential functions that we need to deal with. So we are basically going to be in the medical room. We are going to diagnose these different functions over here, people who claim to be functions, but we need to see are they telling the truth. So we'll diagnose them as either a function or not a function. If they're not a function, that means we cannot continue the procedure further, but if they are a function, we can proceed, and you can see how we'll proceed. So how do we start this procedure? we use the vertical line test, which is essentially us taking a ruler, in our case, and we just flip it vertically, such as this, into a vertical line. And then we can take our ruler around over here, and then we are going to take it to the function, and we are going to scan the function from left to right. Okay, so we're going to scan the function. Okay, I'm going along the function. Okay, that's nice. Okay, I can see here, right? Everything is fine. Now, what am I doing? What I am doing is the vertical line test tests whether there are more than one intersection on the function. So this vertical line touches the graph at 2 points at the same time, then therefore it is not a function. If it only touches the graph at 1 point at every single x value, then therefore it is a function. In this case, do you notice that for every single x value, it has a unique output, meaning the vertical line will only intersect once. So therefore, because our vertical line intersects once only, this is a function. Okay, so we can just say, whoa, I changed the color, that looks weird. So we can say that's a function. Okay. So after we just diagnose the fact that it's a function, we can do the horizontal line test to verify what type of function it is. So we know it's a function, but what type of function is it? Is it one-to-one or is it many-to-one? I'm going to take the horizontal line and I'm going to scan it from up to down. So I'm seeing, okay, it's only intersecting once with the line at every single point. So since there is no point where there's two or more intersections, therefore we call this a what? One-to-one. This is a one-to-one function. Okay. Let's check the other function now. And why on earth is this constantly changing color? I just keep forgetting to select it. It's so scuffed. Okay, but anyway, let's take our vertical line test and test the other one. So now we're going to do what we did in the other one, scan from left to right. So obviously we can see, okay, cool. For every x value, I can still see there's just one intersection every single time, all the way to the end of the function. I know it looks like it can intersect twice, but it never does because there's still unique values. Okay, so since the vertical line test was approved and only intersected once for every single x value, it is a function. Okay, don't do it the way that I'm doing it. I'm obviously doing it the video style way, but you will write down explicitly that it is a function. And then you must state what type of function it is. And how do we know what type of function it is? We use the horizontal line test now. So we scan from up to down, from top to bottom. And what do we notice? As soon as we intersect with this function, it touches more than one x value. Can you see? It touches this point over here. I don't know if you can see it. I'm going to use the mouse. It touches this point over here, and it touches another point also at the same time. So that means since it intersects more than once, this would be considered what type of function? A many-to-one function. Okay. So what type of function are these? This one is a one-to-one. This one is a many-to-one. Let's look at the other ones now. Okay. And there it goes again. Changing the colors. Let's take our vertical line test. Scan from left to right. Oh shoot, okay, so we reached the beginning of the function. Okay, everything looks fine. But as soon as you go more to the right, do you notice that we are actually just intersecting with 2 points at the same time? So it failed the vertical line test. The vertical line is not allowed to intersect twice. Only once. So therefore the answer would be not a function. So it failed. And because it failed, we can't continue the procedure of the horizontal line test. So we just have to move on now to the next function. Let's scan from left to right. Okay, we touched the first part of the function. Okay, it's like a tangent now. It's only intersecting the 1 point. But as soon as you go more to the right, there's an issue. It intersects more than once. So therefore we can say, hey buddy, look here, you're lying to me. You are indeed not the father. I mean, the function. You are not the father. Yeah. So basically, it's not the function. So it's a paternity test for functions, basically. Okay, and because we can't do it, geez, I'm getting a laugh out of this. Because it failed the vertical line test, we don't need to use the horizontal line test because clearly it's not a function, okay? So that's basically the test for functions. That's all you really need to know in these types of cases, okay? So now we are going to go into more types of questions in terms of functions for grade 12.